Welcome back, my friends, to the show that I guess unfortunately never ends. On the, I'm going to call it the healing desk, after a YouTube channel I like a lot. The man calls it the healing bench. This is the dining room table. It's what I got to work on. The cat is finally working. The cat is finally aligned. It's finally working. As you can hear, let's turn the filter off. Let's get all this modulation off, and you will hear. Oh, I got the glide on. So I had this problem with this phasing. I was actually getting a frequency deviation of about 5 to 10 hertz, and it was, if it had been 1 hertz or so, I wouldn't have bothered me. I would have left it. But 5 or 10 hertz is enough to sound a bit out of tune at times. It's like a chorusing effect, and this has no chorus in it. So what was happening? I was thinking that perhaps some of the analog parts became imbalanced. One of the things that happens with these analog synths is you've got an all analog signal path, although not really. I mean, the core level oscillators here, VCO and VCO 1 and 2, are actually ring oscillators, not ring modulators, ring oscillators. It's a bunch of logic gates that are just connected head to tail, head to tail, head to tail, inverting gates, and so it winds up just creating an oscillation up and down and up and down and up and down, and then they use that to create it's actually creating a square wave, but they use it to then generate the triangle and the saw, and the pulse is easy because it comes out of pulse, etc., etc. So that's pretty fixed, but everything else is analog, and in fact, even the tuning is all analog. Everything is just voltages, and this thing is, 30 years old? So electronic parts wear out. I don't know how else to say it, but parts do wear out. Capacitors go dry on you, and you have to replace them. I've replaced all the electrolytics in here. Integrated circuits wear out too. Now, you might not think that because we have plenty of existence cases of integrated circuits not wearing out. But I've been in the integrated circuit business most of my adult life, and I can tell you they do wear out. The ones that are especially subjected to high voltages or high currents are liable to have effects called electromigration effects, where the current actually drags the metal along, and so the metal that forms the wires in the integrated circuit gets dragged until they neck down and pinch off. There's things called hot electron injection effects, which sounds kind of kinky, but actually what it is the transistors, after a while, after being turned on and off, slammed on and off by high enough currents and voltages, some of the electrons don't leave the transistor. Look at it that way, and it creates a permanent voltage in the transistor that makes it more difficult to turn on or more difficult to turn off. I mean, basically, it changes the thresholds of your transistors, and everything goes wonky on you. So yes, integrated circuits can wear out, and there's a whole science of reliability. And trust me, if you've got an electronic pacemaker, the people who built that have spent decades on reliability to prevent the electronic parts in your pacemaker from wearing out, because it takes surgery to go take it out, right? So I was thinking that I had some reliability effects in here. And in fact, I ordered all the components that I could find that match. Now, here's another thing about these synths. You can take them apart, and you can take out these old op amps and say, hey, nowadays op amps are a lot better. Let me put in a higher grade op amp into this thing. Well, guess what? It's probably not going to work, because all of the bias voltages and whatnot have been set up for the way the old components work. Now, if you can find an op amp that's got data sheet specs that match the old components, great. Just swap it out, and it'll probably be more reliable. Integrated circuit processes have improved infinitely over the last 20 years, and so you'll probably get much more reliable parts. However, if you got parts with different specs and you say, hey, I'm going to put this super high-end op amp in here, it's just not going to work. You're going to get some kind of crazy thing happening, because they've set it all up to bias it and to keep the signal path in the sweet spot for the op amps that you got. So you got to find kind of either new old stock parts or parts that have a datasheet spec pretty much identical. That wasn't too hard to do in this case. There's only one chip in here you can't replace, and that's the VCF. It's a single chip VCF, which doesn't exist anymore. The company's gone, and it's, you know, if you want to take that chip out, you got to make your own VCF, which ain't worth it in a unit like this. Now, I went through the whole thing, and I had this weird phasing, and my theory was all of these devices have a transistor pair that's used to regulate the changes in temperature. And here, let me get a schematic. I'll show you. Okay, maybe you can freeze on that. Hopefully, it's way in focus. What I'm talking about here is a transistor pair that's right here, and right here in VCO1, and down here in VCO2. Okay, this transistor pair exists well for a number of reasons. One is it's actually controlling your pedals, and actually I believe some keyboard control comes in here too, down on this side on both of them. But the other side, if you notice, if you actually look at it on the board, there's a big resistor that just sits over the top of the integrated circuit for these things, and that's measuring the temperature of this, and it's adjusting the current that goes into this transistor pair based on the temperature. Okay, that's all nice and cool, but if these transistors aren't identical, if they aren't absolutely identical, let me try focusing on that again. Oh, I think I got it. If they're not absolutely identical, you're going to get an imbalance, and you're going to get some wonky currents flowing around in there. If it was an op amp, you'd call it, your common mode rejection ratio would just go through the floor. I mean, it'd be gone, which means that you're getting common mode signals in there, and that's what this is not supposed to do. This is not an op amp, and that's not the issue, but the main thing is that if they're not the same, current's going to flow that's not supposed to flow. And you'll notice this goes right into, and here's the ring modulator, right? Not ring modulator, ring oscillator. Here it is right here, and it's pulling current down from that, and this is going to control the voltage to this ring oscillator, which is going to make it oscillate faster or slower. And the problem there is that if you've got some wonky current, because these transistors aren't matched, you might change the pitch of the output signal. And that's what was happening here. I was getting this wonky phasing, and I thought to myself, hey, that must be because this particular part, which is a CA3046, it's 5 NPN transistors in a single unit, and it's supposed to be, you know, all identical transistors. They're in a single IC because they're supposed to be brothers of each other, and they're identical twins, exactly for this purpose. I figured mine had gone bad, and in fact, I went out and bought a new, you know, I ordered some new ones. They showed up today. But you'll notice I don't have the phasing. See, he hits the key and nothing happens because he's got no. I got no phasing. That's a pretty constant output. Why is that? Well, here's what I learned, and I'm going to turn it over. I'll take the back off, and I'll show you. No user serviceable parts inside. We'll fast forward through this part. Okay, I know what you're saying. You're going, oh my God, what has that man done to that poor synthesizer? Yeah, I had to mutilate it. And, you know, for a while I was thinking that I wanted to keep it original, you know, bad enough that I put the blue LEDs in there. But I found a problem. So this is the original power supply right here. And this is my new power supply right here. Now you'll notice on the original power supply, I've changed the caps to high-end caps. I've changed the voltage regulators, but to no avail. And I think part of the problem is the components I chose. I've got a 7815, which is I think a National Semiconductor 7815, and then the 7915, which controls the negative rail. It's supposed to regulate the negative rail to 15 volts. doesn't do that. Now, I tried to figure this out. I went online and looked. It's a SGS Thomson 7915, and these are well known to have a certain problem. They don't regulate unless they draw a certain current. Now, I'm drawing that current, but still, the positive rail with the old power supply was 15 volts, no problem. The negative rail was about 14 and a half volts. Now, okay, or maybe even 14 and 3/4 volts. If this was a purely digital circuit, we probably wouldn't even care about that 1/4 volt. We would just say, it's within tolerances, the digital parts take care of it, you're done. Because this is an analog synth, and because this guy depends on minus 15 right there, and then down here plus 15, he's got an imbalance of a 1/4 volt across this very sensitive device, this very sensitive transistor pair, which means current is flowing, at least a 1/4 volt difference, and then whatever the resistance is of those transistors is a current flowing. And that current is modulating this ring oscillator, and it's causing that phasing. So it took me a while to actually come to that conclusion. So what I tried to do was I tried to replace the 7915, but you know what? I didn't have anything other than those ST regulators. And you know, I don't know how they work or what circuits they work in, but they don't work here. All right, so the positive works, the negative didn't work. So what I did was I got another power supply board, I populated it, and I put in 317s and 337s. And what those are regulators that you can adjust. So now I've got a nice adjustment down here, and I can set it up and I can adjust the rail voltages to be exactly 15 volts irrespective of what draw is here. I suspect that the current draw might have been too little or too much for the 7915 ST part. The old part that was in there probably was fine, but the ST part, the new ST part, no dice. So with this, I was able to adjust it, and now I forever have the ability to adjust the voltage on each rail. And as soon as I got 15 volts, positive and negative, the phasing went away, and the thing works beautifully. Other thing I did was I took the keyboard out, and if you notice, these rails are now nice and shiny. I actually took the keyboard out. I tried to remove these rails from their stanchions here, so that I could put Brasso on them or something, but I was unable to do that. They're in there pretty well, and I would have to destructively remove them, and I have no way to put them back on. So I took out all of these little fingers here that go this way, and I then was able to, on each section here, run some brass polish and then clean it off, and now it works. It works. So I'm going to declare the cat piece done now, which means probably I got to get into some music, because playing with the electronics has just been a diversion from why I really have these things, and that's to make music. Okay.